Okay, so we had talked about this last week. Not last week, but the last time we met, we had talked about this. And I'm not going to go back into that. They're basically concepts that help us in controlling the program flow. That's why we call them decision making. Okay, so they try to basically control how a program will be executed. Okay, how a program will be executed. So one of the most important things, maybe I just wanted to highlight on these concepts, are the flowchart. Basically, it will inform you how the whole process moves. Okay, I'd mentioned the last time we met the symbols of flowchart. If I remember, maybe the symbols for flowchart, decision making or decision making in programming. You'll do the design part of it in system analysis and design. So our flowcharts will be very simple. We'll not go into very complicated flowcharts. So like for the if statement, this is the flowchart. For the if statement, this is the flowchart. Okay, so there's an entry here. Always at most of the time we do a novel there just to show the beginning of the program. And of course, another one here just to show that the program is coming to an end. Okay. But now the body of the program or the flowchart is here. Okay, so this is how an if else will operate. This is how an if else will operate. There's a condition to be tested. This is the condition we are talking about here, or the test expression is here. Okay, so this is the syntax, and then this is the syntax. Okay, and this is now the representation, the graphical representation of the flow. Okay, so you check the expression. If the expression is true, you execute some statement or the body of the if. So the statements are here enclosed within the two curly brackets. Okay. If it is false, you don't execute the statement. Instead, you move to the end. Okay. So we normally say you pass the control outside the if body. So you can see how this arrow is moving. Okay. Up to this point. So in other words, if nothing happens here, okay, if nothing happens there because the condition is false, then we move out of this parenthesis. So our execution is moved out of the if body. If it moves out of the if body, that means we are now executing a different line of code, so different programs that are not basically part of the if statement. They are not part of the if statement. Okay, so that's the connection between this if syntax and the graphical or the flowchart design of how the statement is supposed to work. So we'll do maybe one example to sum up everything, and I'll be explaining each area. Okay, so I've just explained how that happens. So our condition is here. Our condition is here. So we are testing if a number that has been entered, okay, the entry was done at that point, has been entered is less than 0, then we display the relevant statement. So our statement is here. Okay, so if this condition is false, then the execution is moved out of the if statement to the rest of the program. So our condition will come, our execution will come to this line here. Okay. So that's what we are talking about the if statement. So what you need to know that most students will always miss is that we have specific way of representing our conditions. And if you've not done this, kindly go and do it within the weekend or today. Check what are logical operators, what are relational operators. Okay. Logical operators and relational operators. You can add with arithmetic operators. The arithmetic are not frequently used in our conditions. Okay. So those are the ones that you use in your condition. Don't write a condition that is in English form. Okay. Ensure that condition is mathematically interpretable. So if it's supposed to qualify as a mathematically interpretable condition, then it means it has to have a logical or a relational operator. A logical or a relational operator. Okay, so simple things like that will really give students a lot of trouble. I remember, I don't know why it happened, but your friends who are in semester 3 now, the exams that you just did online, okay, some of them were copy-pasting programs that belong to C++ language. And my question is asking, you write a program in C language. Okay, you see this, the tragedy. Somebody goes and copy programs that are written in C++, meaning that throughout the semester, the student did not even understand that there is a difference between programming languages. Okay. So those simple things, those mistakes that shows that really you've just passed through this class because maybe you had paid fee or something of that nature, should not arise. Those simple mistakes should not arise. So I'm saying a condition must have a logical or a relational operator. It's not an English statement. Now, so the extension of an if statement is if else. That's just an extension. Okay? Just that an extension. So that it handles the if statement. So you check the syntax on the left-hand side, and you see that we are executing two pieces of statements. Okay, we are executing two pieces of statements, meaning now we have something to tell the user if the condition is false and something to tell the user if the condition is true. Okay? So if you look at the flowchart on the right, then we say if the condition is true, execute this statement. If the condition is false, don't stop, execute this statement. Why is the arrow coming back to this joint here? Why is the arrow coming back to that joint there? It is because an if statement, we normally say, is like a Boolean expression. Okay? A Boolean expression is an expression that will force you to either say true or false, not both. We can't have a statement that is true and false at the same time. Okay? So that expression or the representation of if else is like a Boolean expression. You either be true or it is false, not both, and not none. It has to fall on one of the ends. That's why this line is coming here. So we say if we execute the true point, okay, we'll still come back to the main program. If we execute the false point, we still come back here. And we cannot execute both of them at the same time. Okay? So in if else, we have two statements to be executed, when the condition is false and when the condition is true. So maybe for those who are writing, you always let me know if I'm fast or I'm moving the slides fast. That is, if you're writing, you let me know. Okay, so there's an example here. There's an example here. Hope you can see it clearly. Okay. Now, this example here, this program is checking if an integer is odd or an integer is even. And the integer is entered through the keyboard. The integer is entered through the keyboard or through any other input device. Okay. So I'm saying it is entered through the keyboard because the scanf is here. Okay. Scanf is there. Now, so where does the if statement comes in? Where does the if statement comes in? The if statement comes in when you want to check whether the integer is even or odd. Okay, whether the integer is even or odd. So look at this line here. Look at that line there. Okay, look at that line there. The line is testing whether a number entered at this point. Okay, these are variable called number. You can see the declaration was done here. Okay, so it's checking whether this number that was entered through the keyboard, that particular content that is stored at that location, is even or odd. Now, one of the operators that I was talking about is provided there, is %d, I'm sorry, percent, is percent. Okay, now percent is, when used mathematically in an expression, it's called the modulus. Okay, it's called the modulus. The mod, it's called the modulus. Now, what it returns is the remainder of a division. So, for instance, 4 modulus 2. 4 modulus 2 is supposed to be equal to 0. 5 modulus 2 is supposed to be equal to 1. So it returns the remainder when a division takes place. It's unlike the division, okay, where 4 divided by 2, okay, should be 2. I think so. 4 divided by 2 should be 2. So it's not the same. It's a different operator that returns remainder if a division takes place. So that is why we are saying here that because we know mathematically that an odd number must be divisible by 2 and we have a remainder. An even number must be divisible by 2 and we have a remainder of 0. So that's the mathematical concept that we're bringing on board into programming. Okay, so we are saying if number modulus 2 gives 0, and also something you need to note, how the equal sign is expressed here. It is the double equal in mathematics that we call equal sign in programming. If you write this one alone in programming, we call it an assignment operator. Okay, we call it an assignment operator. It is not an equal sign. An equal sign in C language, and this is specific, because in other languages you'll find it being written differently. The equal sign in C language is the double equal sign in mathematics. That's when you're doing equal, and that's when you're doing comparison. Otherwise, if you use the single one, you are doing assignment. You are telling the program to assign what is on the right to the left. Like when you say y is equals to 2. So you are telling the program, pick 2 and store it at location y. That's essentially what assignment operator will do. Okay, so we are saying if that division gives a remainder of 0, that integer is even. If that remainder gives if that division gives a remainder of 1 or 2 or 3 or 4, depending on what you are dividing, a number other than 0, then that content is odd. So that's the if else. So we have two statements to execute, both for a false result and a true result for the condition. And now that is the kind of practice that is allowed in programming. Even for your phone, if you enter wrong pin, it will not go silent. It will tell you wrong pin. Please try again. Meaning there are two there are two statements to be executed. When you have a wrong answer or when you have a right answer. So if you enter wrong pin, the program or your phone or whatever application you're working on will tell you that these are wrong pin. Please try again. If you enter the right one, it takes you to a different menu or a different page. Okay, so that's the ordinary way of doing programming. You don't do programming and leave the user hanging, that if the condition fails, then the program doesn't display anything. That's not good programming practice. Now, so we have another layered type of if statements. Now we have if else, else. If else, if, then else. So this is one word. Don't make a mistake of putting it with a space. The program, the compiler will not be able to understand. Oh, sorry, not that. Yeah, I'm talking about this. This one word. If else. Don't make a mistake of writing it differently. Now, in this structure, we are simply enlarging the number of conditions the if statement can be able to handle. If I'm working on a grading system for students, then I'll be able to test, maybe for your case, I'll be able to test 4 different grades. Is it 4 different grades? Okay. So I'll be able to check, did you score an A? Did you score an B? Did you score a C? And then did you score a pass or a fail? I'm sure D is a pass or something like that. Okay. So in that scenario, there's need for me to check for 5 different conditions. So how do I do that? If I'm using the if else structure, then I'll be able to do that, because the if else if else is able to handle several conditions. It's able to handle several conditions. So you can check the example so that we understand how that implementation will be done. Okay, so this is how it will be done. This is the syntax. Okay, so you can see this one is expression one. Let's say this is checking whether your max is greater than 80. Whether your max is greater than 80. People who have scores above 80 will score an A. So the statement that we're going to execute here is that the student has scored an A. Okay, this one will check if your max is 70 and above. 70 up to 79. Okay. $70 up to 79. Then we'll tell you you've scored a B. So the statement that we are executing here is a B. This one will check if your marks is between about 60 to 69, I think so. Okay. And it will tell you, you've scored a C. Then we'll say for anybody who's scoring 59 and below, you've failed. Okay. So this is a supplementary. Okay. This is a supplementary. Anything below 59 or no, anything from 59 and below is a supplementary. Okay. So that's how the program should be able to work. So we are trying to test several conditions, and that is can be done if you use this structure here. If else, else if, then else. So else will just be handling the last part. Point to note. If you're using else without an if, you are not allowed to provide a condition. Else without an if does not take a condition. Else alone only picks the other side of the condition that was tested. Okay, so the remaining side that was tested. So if all these conditions have tested these ones, these figures, and it began from 80 going up, then it means anything below 60, the else will take part of it. By default, you don't have to state it here. Okay, because you can rather see the part that is remaining is even bigger than what you've done, from 59 all through to 0. Okay, from 59 all through to 0. So that will be taken by the else part by default. You don't need to specify it. Okay, so that is how the if else will be able to work out. So the if can help you test multiple conditions. If your program is doing a set of several conditions to be tested, then that is the way to go. That is the way to go. So there's an example there. Check out, then you can ask a question. Those who have the compilers can also run the program. Robert, what are you drilling? Unmute yourself if your background has a lot of noise. Okay, so any question on this program? So these are condition 1, we've tested. These are condition 2, we are testing. So only 2 conditions. But now the else part will pick the rest. So we are saying if both test expression is false, then the else part will execute. Okay. If both the 2 conditions are false, then the else part will execute. So basically, we are looking at checking the integers. Okay, so we are saying, is the 2 integers equal? If they're equal, then display integer 1 is equals to integer 2. If they are not, then display results integer 1 is greater than integer 2. So which condition is the else part going to take care of? If you're given 2 numbers, you have 3 options. Either the 2 numbers are equal, either, for instance, if you have the number 1 and number 2, either number 1 and number 2 are equal, or number 1 is greater than number 2, or number 2 is greater than number 1. Those are the 3 options that are there. So the else part will pick a scenario where number 2 is greater than number 1, because that is the condition that has not been expressed here. That's the condition that has not been expressed here. So these are just modified printf statements to print different results. You can run that in your compiler and see exactly what really comes out, how the output will look like. Okay, so it's just a modified one to print a specific output. Okay, any question on that? Any question? Anybody who've not understood? Now, I've said we have 2 conditions. We can say this is number 1. Okay, we can say that is number 1. We can say this is number 2. Okay, so number 1 is basically checking if the numbers are equal. Very direct. Number 2 is checking if number 1 is greater than number 2. And I mentioned that it is only if else if, it's only else if that can be able to take a condition. It's only else if that can take a condition and an if. Else alone is not able to take a condition. It will take the default part of the condition that is remaining. So if you're testing for a true value, the else part will take care of the false value. If there's a false value, or if there's need for execution of the false part of the statement. So these are normal declaration of the variables. Is a normal scanf of the variables. A modified scanf because we are scanning two of them. So let's be keen on how you express your conversion specifiers. How do you put them in place? Okay, so be keen on that. That is if you're using a single scanf statement to scan several or two variables at the same time. So be keen on how you use your conversion specifiers. So more on several conditions to be tested. That's what we mean by nested if-else statement. Just more and more conditions being tested, one inside the other. So that's what we call nested. Okay. Okay. So we say a nested condition or a nested statement is where a statement or a condition is defined inside existing conditions. Okay. So meaning we are testing one or more than two statements, more than two conditions for a single statement. So for instance, I'll say, if you're withdrawing money from an ATM, for instance, the first thing I'll check, the ATM will check your PIN. Okay. So your PIN has to be correct. Okay. Then, if your PIN is correct, you are not allowed to withdraw the money. It's not a guarantee that when your PIN is correct, you will withdraw cash from an ATM. Okay. So number two, the ATM inside this condition. So this is condition one. So condition two inside here would check your balance. That is, if you want to do a withdrawal, it will check your balance. So then inside this one, there will be a condition three that will check the minimum, not the minimum, but the maximum balance, the maximum amount of money you are allowed to withdraw per day. So if you've done previous withdrawals within the day, maybe amounting to 40,000, and your account only allows for 40,000 at maximum per day, then you will not be allowed to withdraw. So that's another condition inside here. So before you come out or you with the money that you want from the ATM, then a number of conditions must have been tested here. Maybe there are more, okay? So all these conditions are being tested courtesy of this withdrawal. So it is only this withdrawal, this statement here, that is making all these other conditions be tested. So that's what we are saying. So several conditions are put within one another just to ensure one statement is executed. That's what we call nesting. You put several conditions together to try and address a single statement. that's how they look like. So that is how those conditions would look like when they're nested. Okay, they're nested. So you must be very, very careful when you're doing your nested conditions. Okay, so that's the same way the arrows are being placed here. The same way the arrows are being placed here. This condition 1 is supposed to be executed before condition 2 can be checked. So meaning if condition 1 is false, even if condition 2 is true, statement 1 cannot be executed. Okay, so if condition 1 is false, the whole of this will not be executed. The whole of that will not be executed. So in other words, the whole of this here, the whole of that is a statement to condition 1. So if condition 1 is true, this block statement will be executed. Otherwise, we'll go to the else. So this else belongs to condition 1. So meaning if condition 1 is false, we execute statement 3. Okay. So that's what is expressed this way. Okay. Maybe let's look at an example if we'll be able to see one. So have a look at that C program. Look at that program. We are picking your username and your password. Okay. And in this our system, security is so high that we check your login credentials one by one. So if your username is true, that's when we check your password. If your username is false, we don't even check your password. Straight away, you are told incorrect username. But if your name is correct, we go ahead and check your password. If it is fine, we give you a message, login successful. If I'm building a system, then I don't only say login successful, but I say login successful and I redirect you to either the home page or the transactional page or whichever page that should move you to the next step. Okay. But now, if your username is correct, your password is wrong, we tell you password is incorrect. So the whole of password execution is a statement that primarily belongs to the username. If your username is incorrect, then whether your password is correct or not is not helping. Because first, your username must be correct, then your password is checked. That's what we call a nested if statement. One statement inside another. Okay? One statement inside another. Any questions? So that's how the nesting goes. Any question? Now, so if the let's move on. Now, before I jump into the loops, let me finish up with another control structure called the switch. Another control structure called the switch. Called the switch case. Hope you, hope you can be able to see that. I don't know how clear it is, but I hope you can be able to see that. Yeah, no, so this is another control structure that performs almost the same thing, like the if, else, if, else structure. So they work almost for the same thing. For they work to achieve, yes? The Mtuko and Naomi, what's the issue there? The font is small, or you can't just see anything that is displaying the screen. What's exactly the story? I've enlarged it again. I think maybe now it's okay. I don't know. That's the maximum it can go. Okay. I've zoomed quite enough. If I zoom then more than that, No, I was lost my connection. Was trying to work on the on the on the audio and disrupted everything that I'd set up. Let me try and share the content again, if it will work through. Now, my application has hung on this end. Not able to stop the sharing of the screen and not really sharing. Now, I hope you can hear me. I experienced multiple challenges from there. The audio was not coming back from there. And now I'll wrap up this, and then we can call it a day. Now, so the switch case is also another technique. I'd mentioned that is being used together. It can be used in place of the if statement, if else if statement. Okay. Now the cases here corresponds to the conditions the other side. Okay. These cases here correspond to the conditions the other side. Then the default statement here correspond to the else on the other side. So this one can be called maybe the else if you like. This can be the if. Okay. So it's just an extended version of what we have talked about previously there. Okay, so if none of the cases are matched, then the default statement is executed. If one of the cases is matched, meaning the condition, let me call them conditions, the conditions test true, then the statement under that case will be executed. The test condition will be here, the expressions that we need to check on. Okay, so what, in other words, what will be switching should be there. So for instance, if you are to check your grade, whether you have an A, B, C, or D, then the expression here is going to be your marks. It's going to be your marks. So based on your marks that we going to receive from you, or we're going to enter, then we'll execute the relevant case here. So we can have case 1. Maybe if your marks is greater than 80, as we mentioned, then your grade is A. Okay, and then the others will take the same effect. Now the break keyword here is used to ensure that the execution of the statements are controlled. Meaning, if case 1 is true, okay, case 1 is true, then only the statement here should be executed. The compiler should not go to case 2. So that's why we're using the break. So the breaks are used to control, or to rather to break the control or break the execution from moving from one case to the other. It's supposed to be restricted under that case and that case alone. Okay, so that's the meaning of the break. Break words. So the .c of course means that you can have as many cases as possible. Case 1, case 2, case 3, case 4, 5, 6, depending on how many conditions you're interested in testing here. Okay, so I've mentioned the explanation here. Okay, the meaning of the breaks and so on and so forth I've mentioned there. So the flowchart is looks like this. The flowchart looks like this. So the expression is here. We'll check for the, so this one will all act as our as our case. Okay, so this might be case 1. Okay, so if it is true, we execute that block. If it is false, we go and check case 2. If case 2 is true, we execute that block. If it is not true, that means it is false, we go to case 3. Okay. If it is true, we execute. If it is not, we go to case 4. If case 4 is also not true, meaning that we've just followed a straight line here. Okay, meaning we've just followed a straight line here. Not true, not true, not true, not true. And all our cases are executed, and none of them seems to match the selection that we are doing. Then we execute the default one. The default one probably is like your calculator. If you punch things that the calculator does not understand, an expression that the calculator is not able to interpret, the calculator will always tell you syntax error. So that is maybe the default statement, that if none of the cases is matched and you no longer understand definitely what the expression here means, then you execute the last resort. Execute the last resort. So all of them are meeting on this line because the same thing with if. It's either true or false. None of will not execute two cases at the same time. It is either we execute block for case A or block for case 2 or block for case 3 or the default. Then the program comes to an end. An example there to illustrate that process. So these are
no. Enable configure terminal. You will go to the sub interface G0.
Okay, so this is an example of a simple calculator that is implemented using the using the switch. So we have the operator. Operator in a calculator is plus, minus, multiply, divide, modulus, and so on and so forth. Okay, so the operator is what we're going to switch. In a calculator, you'll only be switching the operator. Numbers will remain the same. Okay, it's either you're dividing 2 by 4 or multiplying 2 by 4 or adding 2 by 4 or subtracting 2 by 4 and so on. So that's what we're switching. Okay, so the operators are here. Okay, so we ask the operator from the user, give us the operator that you want to work with, and maybe give us 2 operands. Operands are basically the numbers that are going to take part in the mathematical execution. Okay, so we are telling you, give us an operator and then give us an operator. Or we can tell you, give us maybe 2 numbers, then tell us what do you want to do with the 2 numbers, either multiplication, division, subtraction, or whichever mathematical operations can take place there. Okay, then so that's what we are switching. So we are switching the operator. Okay, we are switching the operator there. So if we find a match for what the user entered in representing the operator, we execute that statement. Okay, so we have the first case, option 1, it can be plus. Option 2 can be minus. Option 3 can be multiplication. Option 4, depending on how many we decided to put in place, is going to be modulus. And we don't have any other more option. So we have 5 options. So the first thing is, if the user enters anything that is not similar to case 1 or case 2 or case 3 or case 4, in other words, an addition or a subtraction or a multiplication or a division, if none of those are entered by the user, none of them, okay, none of them is entered, meaning the user has given us a wrong input that the program is not able to understand. What do? We execute the statement under the default. Error, operator incorrect. If, for instance, the user gives us a plus, then it gives us 5, 10. What do? Because we know what to do when the operator is plus. We add and then we execute. So we display to the user maybe N1 plus N2 is 15, something of that nature. Just the same way this will be able to display. So this one will display the numbers first, then it will display the results. You can remodify the printf so that it looks a little bit better in terms of the display structure there. Maybe something that maybe you've not maybe come across before that is showing in this example is basically these ones. These ones are not really important. The whole story there is the F. The F is what is important there. Okay. The others are just controlling how many decimal numbers can be displayed. Remember, we are working with a double here. Okay. So if you work with a double, you're free to use F or you're free to use D. That's basically what's happening. Otherwise, this printf can be written in the normal format that I introduced previously. Okay. So if it is minus, then we'll do the same. If it is plus, we'll do the same. Division and so on and so forth. Now, what you need to take keen interest on, that will make me zoom this thing abnormally, is this. Those quotations and then the full colons here. Very important syntax in a switch case. After the case, you terminate it with a full colon, not semicolon. That's why I'm zooming it up so that you see it. It's not semicolon. Then, if the expression here or the operator or whatever you are testing here is a character, you put it in single quotes. If it is not a character, you don't put it. For instance, if this here was just being expressed as case 1, I'll not put quotes. I'll just put the colons. Okay? Just put the colons. But because I declared them as characters, okay, that's why I'm putting the quotes. In fact, what I want you Okay, so we can stop there. I think I'm having a lot of issues with my source of internet. The power just went off and my Wi-Fi stopped. I think we'll stop there. We'll stop there so that I don't struggle anymore. Let's stop there for today. I'll upload the few notes or the content that I've used in explanation here. You can read them through, but meanwhile, you convert this program into a menu-like program without the characters. So instead, tell the user press 1 for addition, press 2 for subtraction, 3, and so on and so forth. Okay. So unless there's a question, unless you have a question. Any question? Any question? Great. If you don't have a question, I think we can stop at that particular point and see you next week.